Thanks everybody for joining today. My name is Trey Tyler. I'm a Senior Solution Strategist with OVH. Today's topic will be how far is too far, the hybrid cloud distance factor. So a quick disclaimer on everything. OVH is new to the US, so a lot of the things that we'll be talking about today haven't been formally announced in terms of like pricing or all the features that are going to be included, etc. So just know that things that we're going to look at today are somewhat subject to change, just so you're aware. Quick agenda. I'm going to go ahead and introduce OVH. Being new to the US, we'll want to cover just kind of who we are so you're all aware of what we're all about, and then we'll get into the actual meat of the conversation, looking at the challenges of owning a hybrid cloud, what that means and what difficulties you might run into, what OVH can do to help, and then we'll have a quick Q&A session, and then also some more info on where you can find us at VMworld, run into us or check us out on social media, things like that. So who is OVH? OVH is probably the largest cloud provider you've never heard of before. We're the largest cloud provider actually in Europe. We've been around since 1999. In 2016 we had 20 data centers in 5 different countries, and in 2017 now we have 27 different data centers in 11 countries. According to netcraft.com, we're the 5th largest cloud provider or hosted provider in the world. We currently have our data center footprint can house up to 1.3 million physical servers, but currently we have deployed about 260,000 physical servers, and we have over 1.2 million business customers at this point. We do build all of our own data centers. There's actually a function of the data center itself, the shape of it. As you can see here, all of our servers that are deployed in there are all created ourselves. So what I was saying about the function of the data center, so everything is either liquid cooled or open air data centers. So the shape of the building itself actually has a purpose, the way that we're pulling air in. There's actually vents that we can adjust to either bring in more or less air depending on the temperature outside, the temperature within the data center, and things like that. So because of this, because of the way that we're water cooling everything and using natural just airflow, allows us to be incredibly efficient, which gives us really the best performance per value. It allows us to be way more efficient and pass that on to our customers. So all of the servers we compile and build ourselves. We source them from other providers as far as like the motherboards, the CPU, things like that. But the water cooling is all proprietary. We pull in the tubing. We actually carve out the copper heat sinks and carve in the maze for the water to go through and things like that. We do build the server housings. We build the racks and everything else from the ground ups. And together we're bringing this together for the US. We'll have 3 initial offerings. That we're going to have a hosted private cloud, which is built off VMware's SDDC stack. This is vSphere as a service. You have access to vCenter, you have access to the hosts, you're in charge of configuring the networking, you're in charge of setting up DRS, affinity rules, anti-affinity rules, so on and so forth. You have full control over that. We do have a public cloud offering as well. This is all built off OpenStack. So if you have virtual machines that you want to create and scale out horizontally to maybe tear them down, they're more disposable VMs. That is a great place to do something like that. And then if ultimate control is what you're looking for, we do have dedicated bare metal servers as well. So we give you the hardware, you have KVM access through a Java applet, you install your own OS, you do whatever you want. So you can even do your own vSphere deployment from a dedicated server standpoint if you need more control than whatever it is that we give you. A few other little tidbits at the bottom. OVH does have a fiber optic backbone that we own between all of the data centers that we allow customers to take advantage of. Each of the data centers that we have has a homegrown anti-DDoS solution between all of them, and this does protect each of these 3 products. It is included with the service. And the private VLAN is actually referring to a product we have called VRAC, which is also included. Right in that fiber optic backbone, we're able to allow customers to connect all of these different environments, either within the same data center or in different data centers across the globe, we can connect all of the VLANs that you use for each of these all together. So it acts as a single layer 2 domain space. So that's real quick on who OVH is. So let's get into the meat of it on the challenges with the hybrid cloud. So hybrid cloud is a big buzzword, mainly because not everybody's fully committed to cloud. Maybe you've got certain workloads that you have to keep on premise. You can't just move everything to the cloud. And if you look at it from a marketing perspective, it's probably all clear skies and easy because you just hear all the good stuff. But if you've actually worked, maybe you've tried to implement your own public hybrid cloud, you'll come to find out that there are some things that you'll run into during your implementation, details that got overlooked, capabilities that are missing that you had either assumed were going to be there that weren't, so on and so forth. So I've compiled a lot of the issues that we've ran into in the past, that I've seen in the past, and broken them up into 3 different columns. So on the left-hand side, we've got mostly networking-based issues with hybrid cloud. So whether it be latency, bandwidth, security, the availability of the network, how you have to design your networking to make hybrid cloud work, connectivity, flexibility. The centerpiece of it is mostly around hardware, so I am including co-located resources here as well. Some customers do want to kind of build their own hybrid solution by using someone else's data center, and we'll talk about all the things that are involved with that as far as taking your hardware there, deploying it, and then how you maintain that. Do you hire someone else that's local to the area that has the skill set, or do you travel? And then over on the right, we'll talk a little bit more about people as well. If you're going to use someone else's cloud, do they already have the technical experience? Do they know the CLI commands? Are they used to that API for that particular cloud provider? If not, maybe you have to hire someone new or you have to train. And then at the very bottom, we've got loss of control and visibility, which we see all over the place, where you move to a cloud provider and now all of a sudden you lose visibility over everything all the way down the stack. So you're left kind of guessing what's actually going on. You have to open up a case, call the cloud provider, and you're at their mercy to find out what exactly is going on here. And a quick little animation. All this makes the cloud seem a little further away, your hybrid cloud. So where can OVH get involved here? So first let's take a look at latency, bandwidth, and security. So latency is a tough one to address here because you can't really bend the laws of physics. You can yourself go ahead and seek out some sort of SD-WAN capabilities, look at WAN optimization, and some of the techniques that they're doing can help lower the latency for traffic overall. You can go ahead and order your own dedicated circuit to reduce the hops between your environment to the cloud that you're connected to. And then security, either if you have a dedicated circuit, it's relatively secure, or you're going to be connecting over VPN, or you're going to have users connecting direct through SSL VPN, and things like that. There's a lot of questions around that and what it means. So OVH's answer to that is, as much as we can, is we own the backbone. So this is a quick map over the US and the fiber that we own here already. Each of the blue lines is going to be a line between data centers. The pink icons there are going to be where we have internet access. And then the green and the dark green and the light green bordered are either just a point of presence where you can bring a dedicated circuit from your on-premise environment and connect to the OVH network, or there's a CDN located there. This is a global network that connects to all of our data centers, so we're not only in the US, we own the backbone over here in Europe as well as Asia Pacific as well. So customers bringing your environments to OVH, you can take advantage of this backbone to communicate back and forth between the data centers, or if you bring a dedicated circuit to an OVH POP, you can leverage this to help reduce the latency. You can take advantage of the bandwidth and throughput capabilities there as well. And also, since your data is not traveling over the open internet at that point, it should be more secure. Of course, you'll still want to secure that traffic anyways, but that is what OVH can do from there. So next we'll look at security and network availability. So moving your data to the cloud, you might be worried about who your neighbors are, whether or not they're a hot target for a DDoS attack or something like that, because you could be collateral damage and your environment could suffer outages due to who's next to you when you're in a cloud. And the availability of that network means a lot to you. So if they get under attack and the services go down, you're subject to that as well. We saw that last December on the attack for Dyn. Dyn went down, the whole Eastern Seaboard had lost a lot of services for a while. So each of our data centers, we've deployed our own homegrown anti-DDoS solution. This is a quick shot of what that actually looks like. So this is something that we built ourselves, and we call it VAC because we're essentially, when we're recognizing that there's an attack, we'll vacuum the traffic in from the main point and then go through these 4 different filters here before we allow traffic to pass on to your servers. So the 4 parts of this, we have our pre-firewall, which is just a pre-configured ACL that sits up front for a lot of known types of attacks. So for instance, like UDP over port 80, we'll just be blocking that by default. The firewall portion of it is unique because this is actually configurable by you. You can choose the public IPs for your virtual machines and either proactively add them to the VAC system and configure your own pre-firewall, or you can leave it outside of the VAC system and we'll automatically add all of the public IPs in that location to the VAC system once we've sensed that there's an attack that's happening. From there, we'll move on to Shield, which is mostly going to handle UDP forms of attack. And then lastly, this is only enabled actually when we're under some sort of attack, is Armor. And this really does the grunt of the work across the board. It's going to look at the behavior of the traffic, making sure that there's not just a ton of different, like the SYN authentication, making sure it's not the same packet over and over again from there. So to expand upon this, this is just all in a single data center, right? So this is just in one location. But that's not really enough for some of these large attacks. The attack on Dyn this last year was around a terabit per second, and that's what had taken that out. So because we own the backbone between all these data centers, we actually can leverage these VAC systems across the board between each data center. So once an attack gets sensed here, we can pull traffic into each of these locations and horizontally scale to thwart these attacks. There's actually a link here on the bottom left that goes over an attack that happened just a few months before Dyn went down. It was in September, and it was around a terabit per second attack that we were able to manage. Our CEO, Octav, was actually tweeting about it while it was happening. Pretty interesting stuff. The only, I guess, downfall from that is customers didn't have any outages. Their traffic, their servers were still able to respond to legitimate traffic, but they did see higher latency during the time, of course, because of the paths that the traffic is taking. You would expect that to take a little bit longer, right? And then lastly, we'll move to design, connectivity, and flexibility. So this is where I think I see most issues when customers are thinking about hybrid cloud is, how do I connect everything together? How is this going to talk to this? What do I do from networking space? Do I have to create all new networks? Can I use one of these fancy stretch networks? If I'm co-locating, could I use Cisco equipment to extend layer 2? Or if you've ever used vCloud Air before, we used HCM a lot to extend layer 2. And this is where you'll spend a lot of time trying to discuss these things. And OVH has, this is probably my favorite thing to respond to that, is VRAC. So VRAC is a solution that we've created it's comprised of switches that are all aware of VXLAN segments, and they have hardware VTEPs. So essentially what we can do is encapsulate all of your VLANs that you're using with each of your environments, and we can share that same space between data centers or between environments within the same data center or across the globe. We have that backbone, so this can ride along with that. So here, this image is showing, I've got 2 different types of environments. I've got the OpenStack public cloud environment right next to a vSphere as a service private cloud environment in Vint Hill, and they're all connected with each other over to Hillsboro and then over to Roubaix. To take that further, we have VRAC Connect, which is where you can bring your own dedicated circuit to an OVH point of presence, connect to there, open up a case, and give us your VRAC identifier. We'll find out what the corresponding VNI is for VXLAN and make sure that we're trunking all of your VLANs there. And all of that traffic can be shared to Roubaix, Hillsborough, and Bent Hill. If it's all riding on the same VRAC, it's all the same layer 2 space. So VLAN 1 at the customer DC here, if you're sending traffic to, I don't know, from VLAN 10 to VLAN 10, all of you can access that on any of these other locations. Didn't change my slide here. Didn't change it at all. So this is a quick image on what this actually looks like. So down here at the very bottom we have the hosts, right? And at the host level you'll be tagging at the VDS to see VLANs 1 through 4,000, let's say. As we move up, we'll take those VLANs and we'll put them in a Q&Q VLAN, and that identifier will be that particular customer's Q&Q ID at the next step for our host switches. As we move up the stack, we'll go ahead and we'll rip off the Q&Q and we'll put this in a VXLAN segment. At the local area, the Q&Q ID that we rip off and the VXLAN ID will be married to each other. There'll be a 1-to-1 ratio there. And then from there we'll go up the stack. We can cross over to the spines or super spines if we're saying within the same data center, or travel all the way up to the backbone and over to another data center for communication. Back to the marriage of the Q&Q and VXLAN. The reason we do that is because when it comes back down in data center 2, the Q&Q ID might be different. They can't always be the same. So we'll just do the same thing there. We'll pick whatever Q&Q ID that you have there and we'll marry it to that VXLAN as well, just to make sure that we can continue to scale. The number that's shown here was changed. It should be 64 billion customer configurable VLANs. So these are 64 billion customer VLANs that can be stretched on a global scale. So that same network is accessible at all of the different data centers. And it's very simple to set up. The first time I saw this, I couldn't really believe it. I went and bugged the heck out of all of the developers saying there's no way that this is what it's like. This is a quick shot of OVH Manager. It's where you manage all of your environments and features. And this is the VRAC UI. So on the left you can see the eligible resources that you have. It'll list out all the environments that are eligible for VRAC. You can simply just click it and add it to your VRAC environment. All of the environments that you want to be connected are all listed on the right hand side, and they're all within the same VRAC. Those will be able to communicate with all of your VLANs. And from how this looks from VMware, we'll have two different VDSs. You can see the VDS on the top is actually for OVH management. That's how you connect to vCenter. That's how you connect to your storage. That's where you gain internet access. But the VRAC VDS is where all of that layer 2 communication between those environments happens. So next we'll move to the centerpiece, which is about around the initial setup and maintenance and management of that environment. So this can be a real pain, especially if you're co-locating. It's almost more of a pain than it's worth in some cases. So if hardware dies, you have to have someone go out there and replace it. Of course, you probably have some redundancies built in, so it's not an immediate emergency, but you still have to get that done. And you have to deal with everything that's listed out here. OVH's response to this is the way that everything is automated. So the vSphere as a service offering that we have, the initial provisioning is all done through automation. So if you submit an order, we're not having a bunch of people go and configure after you've placed the order, the vCenter, and connect all of your hosts and setting everything up. In Europe, they're actually delivering this within 30 minutes of the order. An entire new environment, vCenter connected to the hosts. The same thing can be said for the quick addition of physical hosts to the environment. So we have a bunch of these resources just sitting available for customers. So, and we've written plugins for the web client and thick client, so it's all within the same interface. If you just right-click on a cluster, you can hit Add New Hosts, and within 8 minutes or so, they'll add you a new host to that particular cluster. You remove them the same way. Just right-click on the cluster and remove a host. From a provisioning, from a PCI standpoint, that's just a few minutes. It's just a virtual machine. You can just spin those up. The way customers are using that in Europe really is mostly through API. So you're creating hundreds of virtual machines at all at the same time. And then the last thing we've got here is mostly for host replacement and maintenance and things like that. So in our environment, if a host resource dies, if a processor dies, if the memory is bad, and it's just not functioning and it goes down, we're monitoring all of this. So within 10 minutes of a failed sensed host failure, we'll add resources right back to your environment. You don't even have to call us to tell us about it. You can, but we'll be taking care of it anyways. And then the last column we'll look at the people as a whole. So again, back to are they going to have the technical experience with this particular product that we're looking at, for whatever cloud provider, their UI, their API, their CLI, do I know how to manage all of this? And even after they've trained on how to install and configure it, troubleshooting is a whole nother story in itself as well. Because of things like that, project timelines might get stretched out, or you just need to hire new people entirely. From OVH, this is vSphere as a service. It's the same interface, it's the same tools that you've been using. You can integrate third-party products. You have access to the vCenter. Your admins should already be experts at all of this, right? So this should help save time across the board. The SDDC stack that's going to be provided to the US is going to include vCenter, NSX. VROPS will be an optional add-on, and you do have control of all the features that are listed out here as well. A quick image on the actual architecture of this and what it looks like from a very high level is here. So you can see the resource pools, the storage, and the hosts are what you have control over and manage, and of course the networks there. All of the management virtual machines though, vCenter, NSX, the control cluster for NSX, VROPS, any add-ons, anything like that are all pulled off of your compute stack. So we don't make you pay for resources to run your management stack. We take care of all of that for you. So that's running on our hardware, and we're not taking, there's no overhead involved with that. So you have full access and control over the resources that you've got there. This is something that's huge when it comes to that, because you could end up buying several additional hosts just to run those resources. And then for our last step, we'll look at people, again, traveling and telecommunicating. So if you ended up getting a colo space and you have to have somebody out there or not, are they going to travel, or are you going to have to telecommunicate to plan for projects, things like that? And then the big two things that I see are the loss of control and loss of visibility. We experienced this firsthand with vCloud Air, because you're all the way up the stack, you're only managing from VCD, you can't see vCenter, you don't really know what's going on under the covers, you have to open up a case, you have to wait for us to call you back to see what's happening. OVH is incredibly transparent and gives you amazing access. With our dedicated servers, you can, if control is what you're looking for, go with dedicated servers. You get access to KVM. Simply just go into your OVH manager, find the machine you're looking at accessing, and you can open it in your browser with HTML5, or just open up a Java applet, and then you've got KVM access to that machine. As easy as that. From a visibility, we have created a solution that comes with all of the vSphere as a service environments called vScope. So what this is doing is pulling all of the metrics and information that vCenter is gathering over time, and it's giving it to you in a single pane of glass. So it's not quite as robust as something like VROps, but this is a much easier way to get reporting from a daily, weekly, annual basis on your virtual machines, whether it be the virtual machines or the physical resources that's supporting that. This is from memory, compute, and storage, or even networking metrics. For transparency, this really blew my mind when OVH acquired vCloud Air, and I discovered that they have these things out there publicly to look at, because it's unheard of. So we have two different sites. You're welcome to download this solution deck after VMworld. It'll be available on the site. You can click on these links to go and look at OVH's page. But for our real-time monitoring, this is actually a shot of part of one of our data centers where you can see all of the individual nodes, and they'll be colored whether they're down, whether they're rebooting or they're under maintenance. And then for our weather map here, this is actually part of a data center that's showing you all of the network connections between different areas of the data center, and you can see what the actual workload is at any point in time here as well. So if there's something funky going on with your environment, you can come and actually look in here if you know around where you're at and say, hey, there's something wrong with the actual physical hardware. I see that there's a lot of stress on these particular connections. Something else that we have as well is smokeping.ovh.net. From each of our data centers, we're constantly pinging various different locations in between data centers to help show latency for people that are looking at coming to our environments, and this is all graphed over time. Latency can be a big deal when you're looking at setting up another environment somewhere out in the distance. So, and there's really no way to know what that's going to look like until you've already done it. So that using smoke ping is a great way to get a good look at what is it going to be, but from Palo Alto, California to Hillsboro, the way that over that backbone. So all of this adds up to OVH makes it easy to, you don't have to compromise from a control perspective, you don't have to compromise from performance, so on and so forth. Since we've built everything from the ground up, from the data centers, the servers, the racks, we're able to have the highest efficiency and give you the best value for that. And we really do believe that you should have as much control as possible in your cloud. This is was the biggest thing to me coming over from vCloud Air to OVH, was how much control customers have. You're not so extrapolated away from the environment that you're having to call and ask someone else to do something for you all the time. Of course, you can get further like that if you wanted to. If you wanted to be so removed from the hardware, you can go with something like OpenStack. But I think most folks are looking at what they're used to. It's easier to accept a vSphere as a service environment because that's what most admins are doing today. And if it's the same tools, it just makes it so much easier to get going. And that's everything I wanted to bring up. So this is a good time for Q&A. If anybody has questions, we have the microphone in the middle. If you don't want to move, just raise your hand. I'll repeat the question for the recording. Sure.
So for the dedicated environment, are you using VMware for that?
For the dedicated, okay, so the question was for the dedicated servers, are we using VRAC for that? The dedicated servers can take advantage of VRAC, absolutely, yes. So you can interconnect a vSphere as a service environment to a dedicated server to a PCI instance, and they can all share the same networking space.
And just one more.
Uh-huh.
So in a dedicated environmental environment, what is the storage?
What is the storage? So it can be local storage on the server. So you choose when you're ordering the hardware. You choose what the hardware is. There'll be various options from a compute and memory standpoint, but also what the local storage is going to be. Or you can use like NFS storage on a NAS as well. You can order multiple different servers for that. It just depends on what you're going to be looking for. Unfortunately, because we haven't made any official announcements on what's going to be available, I don't have any information just yet. I do know that we will be making announcements on what will be available in the US very soon. Mm-hmm. So if you come up with questions later on, we are a Diamond sponsor and we're at booth 406. We're doing very cool caricatures if you wanted to go get yourself drawn. It's pretty unique. We've got multiple demo stations. I'll be manning the data center extension, and you can actually see VRAC firsthand and how that actually works. We'll set up a couple different virtual machines, show that they don't ping, simply add them to VRAC, and all of a sudden communication is up. We also have a couple things from like a Zerto as a service or Veeam as a service within a PCC environment where you can see kind of how those are working. And then one of the other guys built I think he did a VDI deployment just to show like what you can do and that you can access the hosts or vCenter to set up something like that. So there's a lot of different demos you can look for. There's more information there as well. This is how you can get a hold of us. And then there are a couple other sessions as well that will be coming up that you're welcome to go see later this week. All right. Well, there's no more questions. You guys are free to go. Thank you very much for joining today. I appreciate it.